chemcrackers. Today we're looking at molar masses. In the previous video, we linked the relative mass scale to the absolute mass scale. And that linkage was brought about by Avogadro's constant, the mole of atoms, 6 times 10 to the 23 atoms or particles. In the previous video, we used magnesium to demonstrate the link between the relative mass scale and molar mass. Now, the relative mass of magnesium, the magnesium atom, is 24 AMU. But if I have 6 times 10 to the 23 atoms of magnesium, it actually weighs 24 grams. That's an absolute mass that we can weigh on a scale. So the link between relative mass and molar mass, that is absolute mass, is the mole. So today we're going to define molar mass and do calculations involving the mole and masses of particles. Let's define molar mass. Molar mass, as the name suggests, literally means the mass of 1 mole of a substance. Literally, that's what it means. Now, 1 mole, we already established what that is in terms of the number of particles. So you could have an alternative definition as mass of 6 times 10 to the 23 particles of a substance. Alright? So we can define molar mass as the mass of 1 mole, or the mass which contains L particles of the substance. Now, let's see if we can do this, if we can apply this in some calculations. Let's look at this question. What is the mass of 2.5 moles of oxygen? The relative atomic mass of oxygen is 16. So, if we look carefully, we can figure out the relationship that this is asking us about. It says, what is the mass? So we need to determine mass, and we are given moles. Now that relationship between mass and moles is given by the molar mass. So we must know the molar mass of the substance that is being talked about. And this substance is oxygen. And the first thing that we must know is that oxygen exists as O2 molecules. Okay? That's how oxygen exists. So if we want to get the molar mass of oxygen, that would be 2 times 16, and that is 32 grams per mole. Oxygen has molar mass 32 grams per mole. And that means that 1 mole of oxygen weighs 32 grams. Now the question is asking you, if I have 2.5 moles of oxygen, what is the mass of that? And so it is a simple matter of working that out. If we replace the question sign by x variable, then x is going to be equal to 2.5 times 32, which is equal to 2 times 32 is 64, and half of 32 is 16, so that is 80 grams. And that's your answer. Let's try another one. This question says, how many moles are present in 20 grams of calcium carbonate? Okay, so the question is asking us about the relationship between moles and mass of calcium carbonate. So we need to know the molar mass of calcium carbonate. Now you're given the relative atomic masses of the relevant elements there. So if we can determine the molar mass, that would be our first step. So if we get the MR of calcium carbonate, that would be 40 times 1, because we have 1 calcium atom, plus 12 times 1, we have 1 carbon atom, plus 3 times 16, 3 oxygen atoms. If we add that up, 40 plus 12, that's 52 plus 48, that's 100 grams per mole. That is the molar mass. Now, if I just cut the board in two there, I'm going to say, okay, so 1 mole of calcium carbonate is 100 grams. And the question says, if I have 20 grams, then how many moles would I have? And the question we can work out easily by making x the subject. So x will be equal to 20 times 1 over 100, which is 0.2. So our answer is 0.20 mole. Now, from this question, we could actually derive the formula for this calculation, because this 20 here was the given mass, the mass given, and this 100 was the molar mass. So this is given mass, and that is molar mass, right? And we worked out x, which was the mole, right? So from this we can figure out that mole equal given mass over molar mass. And that's a formula you can use for the relationship between mole and masses of particles. Mole equal given mass over molar mass. Now, as I said, I don't recommend that you swap the formula, but if you can derive it like this, it's even better. See you next time on Chemcrackers. Don't forget to share the video, like the video, and subscribe for more chemistry crackers.